Welcome to the lecture number 8 on conic sections. In the last lecture, we studied about the equation of tangents and normal to a parabola. In this lecture, we will study about ellipse. So, let me start with points of intersection. Of line y equal to m x plus c with the ellipse x square by a square plus y square by b square equal to 1. So, we have this ellipse this is a 0 minus a 0, this point is 0 b and 0 minus b, and we have some line y equal to m x plus c. So, as you can see from the picture, there are three possibilities. This line might intersect the ellipse in 2 points, or this line might be like this when it does not intersect the ellipse, and the third case is that the line can intersect the ellipse in only one point. So, we will derive the condition for all these three cases. So, putting y equal to m x plus c in the equation of ellipse gives x square by a square plus y is m x plus c, m x plus c square by b square equal to 1, and then we have to solve for x from this equation. So, this is same as b square x square plus a square m square x square plus 2 m c x plus c square equal to a square b square, and this gives us a quadratic equation in x which is a square m square plus b square x square plus 2 a square m c x plus a square c square minus b square equal to 0. So, this is a quadratic equation in x, and its discriminant d is equal to b square minus 4 a c, it is 2 a square m c square minus 4 times a square m square plus b square times a square c square minus b square. This gives discriminant is 4 a to the 4 m square c square minus 4 a to the 4 m square c square plus 4 a to the 4 m square b square minus 4 a square b square c square plus 4 a square b to the 4. So, this cancels and this can be written as 4 times a square b square is common and then we get a square m square minus c square plus b square. So, we know that we have 2 points of intersections. If D is strictly positive, that is if c square is less than a square m square plus b square, and there is only one point of intersection, this means that the quadratic equation has real and equal root, which is for d equal to 0, that is c square equal to a square m square plus b square. And no points of intersection. If d is less than 0, that is if c square is greater than a square m square plus b square. So, one conclusion from this is the line y equal to m x plus c is tangent to the ellipse x square by a square plus y square by b square equal to 1 if and only if c square is equal to a square m square plus b square. So, this is the condition for the line to be tangent to the ellipse. Next, let us try to find what is the length of the chord. Length of the chord joining 2 points, let us say x 1 y 1 and x 2 y 2 on the ellipse. So, suppose there are these 2 points on the ellipse, this say x square by a square plus y square by b square equal to 1, then we want to find what is the length of the chord. So, we have this ellipse and we have any 2 points. We want this length. So, what we have seen is that if we know the equation of the straight line in the form y equal to m x plus c, then we know the points of intersections are given by roots of a quadratic equation. So, the line, the equation of the line joining x 1 y 1 and x 2 y 2 is given by y minus y1 equal to slope is y2 minus y1 by x2 minus x1 times x minus x1. So, this is same thing as y is equal to y2 minus y1 by x2 minus x1 times x plus y1 minus y2 minus y1 by x2 minus x1 times x1. So, that means that this is the value of m and this is c for this line. Now, we know that x1 and x2 are roots of the equation, x1 and x2 are the roots of the quadratic equation that we derived in the previous slide. So, this is the equation whose roots are x 1 and x 2. So, let us write it down, a square m square plus b square x square plus 2 a square m c x plus a square c square minus b square equal to 0. Now, we know that if x 1 and x 2 are roots of a quadratic equation, then we can write down formula for x 1 plus x 2 and x 1 times x 2. So, this implies x 1 plus x 2 is equal to minus of the coefficient of x divided by the coefficient of x square, and x 1 times x 2 is equal to a square c square minus b square by a square m square plus b square, where m and c are given as a verb. Now, length of the chord is L equal to square root of x 1 minus x 2 square plus y 1 minus y 2 square, but this can be written as x 1 minus x 2 square plus y 1 is m x 1 plus c and y 2 is m x 1 m x 2 plus c. So, c cancels here and we get this is equal to square root of 1 plus m square times mod of x 1 minus x 2. So, we need to find what is mod x 1 minus x 2 and then we know the length. So, x 1 minus x 2 square is nothing but x 1 plus x 2 square minus 4 x 1 x 2. So, if you substitute the value of x 1 plus x 2 and x 1 x 2, this gives 4 a to the 4 m square c square divided by a square m square plus b square squared. This is x 1 plus x 2 squared minus 4 times x 1 x 2 is a square c square minus b square divided by a square m square plus b square, and on simplification this gives we have a square m square plus b square squared in the denominator and the numerator becomes 4 a square b square times a square m square plus b square minus c square, and therefore, mod x 1 minus x 2 is the positive square root of this. So, that is equal to 2 a b times square root of a square m square plus b square minus c square divided by a square m square plus b square, and length L is square root of 1 plus m square times this mod x 1 minus x 2. So, we can find the length of the chord joining any 2 points on the ellipse using this formula. So, next we will derive what is equation of the tangent. Equation of the tangent at the point x 1 y 1 to the ellipse x square by a square plus y square by b square equal to 1. So, we will do this in two different ways. The first one we will do using what we have just done. So, let the slope of the tangent at x 1 y 1 be m, then the equation of the line is y minus y 1 equal to m times x minus x 1. That is y is equal to m x plus y 1 minus m x 1. So, let us put c is equal to y 1 minus m x 1. So, we have equation of the line of the form y equal to m x plus c, and we know the condition when this line is tangent. So, we know that the line y equal to m x plus c is tangent to the ellipse x square by a square plus y square by b square equal to 1 if and only if c square is equal to a square m square plus b square. This is the condition for the line to intersect the ellipse in just one point, in which case it will be tangent. So, this is same thing as c is y 1 minus m x 1 square equal to a square m square plus b square, and this gives this, you can see, is a quadratic equation in M. This is equal to x 1 square minus a square m square minus 2 x 1 y 1 times m plus y 1 square minus b square equal to 0. And this gives, here note that the discriminant d is equal to 4 x 1 square y 1 square minus 4 x 1 square minus a square times y 1 square minus b square, which gives d is equal to 4 times a square y 1 square plus b square x 1 square minus a square b square, which is same thing as 4 a square b square times x 1 square by a square plus y 1 square by b square minus 1. But x 1 y 1 lies on the ellipse. So, this is equal to 0 since x 1 y 1 lies on the ellipse. So, thus the quadratic equation in M has the only one real root given by, therefore, M is equal to 2 x 1 y 1 divided by 2 times x 1 square minus a square, which is same as x 1 y 1 divided by x 1 square minus a square. So, this is the value of the slope of the tangent line. Now, we will write the equation. So, the equation of the tangent line is y minus y 1 equal to m is x 1 y 1 by x 1 square minus a square times x minus x 1. And this gives so we have y minus y 1 equal to x 1 y 1 by x 1 square minus a square x minus x 1 square y 1 by x 1 square minus a square. So, if we multiply this equation by y 1, we get y 1 minus y 1 square equal to x 1 times y 1 square by x 1 square minus a square x minus x 1 square y 1 square by x 1 square minus a square. Which I will write as y 1 equal to y 1 square by x 1 square minus a square times x 1, and then I have plus y 1 square times 1 minus x 1 square by x 1 square minus a square. So, let me rewrite it as y 1 equal to y 1 square by x 1 square minus a square x 1 plus y 1 square, and this quantity is x 1 square minus a square minus x 1 square. So, that will be minus a square by x 1 square minus a square. So, this is equal to y 1 square by x 1 square minus a square times x 1 minus a square. Now, note that x 1 square by a square plus y 1 square by b square, this is equal to 1 because it lies on the ellipse, and this gives b square x 1 square plus a square y 1 square equal to a square b square, which means b square times x 1 square minus a square equal to minus a square y 1 square. So, what we have here is y 1 square by x 1 square minus a square. So, this will write as y 1 square by x 1 square minus a square is equal to minus of b square by a square. So, we put it back in this above equation to get y 1 equal to minus b square by a square x 1 minus a square. Which is equal to minus b square by a square x 1 plus b square. So, this we can rewrite as x 1 by a square. By dividing the above equation by b square, we get x 1 by a square plus y 1 by b square is equal to 1. So, we will remember the equation of the tangent line at point x 1 y 1 to the ellipse as in this form. So, this is equation of tangent at x 1 y 1. So, next we will derive this equation again. For those of you who have learned calculus, it can be derived much more simply. So, another way using calculus, so we have x square by a square plus y square by b square equal to 1. Now, if we differentiate this, with respect to x, we get 2 x by a square plus 2 y dy dx by b square equal to 0, which implies dy dx is equal to minus b square by a square times x by y. Now, if you know that the slope of the tangent line is nothing but the derivative at the point x 1 y 1. So, recall slope of tangent to a curve y equal to f x at point x 1 y 1 is m equal to dy dx at the point x 1 y 1. So, therefore, the slope in this case will be minus b square by a square times x 1 by y 1. Now, once we know the slope, we can write down the equation. Therefore, equation of the tangent is y minus y 1 equal to slope is minus b square by a square x 1 y by y 1 times x minus x 1. Which gives y minus y 1 equal to minus b square by a square x1 by y1 x plus b square by a square x1 square by y1 multiply by y1, this gives y1 minus y1 square equal to minus b square by a square x1 plus b square by a square x1 square. So, this gives y1 plus b square by a square x1 equal to y1 square plus b square by a square x1 square, which is same thing as writing y1 by b square plus x1 by a square equal to y1 square by b square plus x1 square by a square, but this is equal to 1 because x1 y1 lies on the ellipse. So, we get the same equation x1 by a square plus y1 by b square equal to 1. So, this is the equation of the tangent line at the point x1 y1 to the ellipse x square by a square plus y square by b square equal to 1. Next, we will derive the equation of the normal to the ellipse x square by a square plus y square by b square equal to 1 at the point x1 y1. So, what is normal to a curve? It is the line which is perpendicular to the tangent line. So, this is a tangent line and this one is normal. So, we already know that the slope of the tangent we saw that the slope of tangent at x1 y1 is minus b square by a square x1 by y1. Therefore, slope of the normal at x1 y1 is given by m equal to minus 1 by this, which is a square y1 by b square x1. Once we know the slope, we can write down the equation. Therefore, the equation is y minus y1 is equal to m times x minus x1, which we will write in this form, that is x minus x1 divided by x1 by a square equal to y minus y1 by y1 by b square. This is the equation of the normal line. Next, we will discuss the parametric form for any general point on the ellipse. Parametric form of a general point on the ellipse x square by a square plus y square by b square equal to 1. So, any point x comma y on the ellipse satisfies x by a square plus y by b square equal to 1. So, from this we can easily see that we need the x by a and y by b such that the sum of the square is equal to 1. We know that cos square theta plus sin square theta is equal to 1. So, putting x by a equal to cos theta and y by b equal to sin theta, we see that x equal to a cos theta, y equal to b sin theta gives any point on the ellipse for theta we can take between 0 and 2 pi. So, the parametric form we will take as any general point P on the ellipse can be written as a cos theta comma b sin theta. Now, let us see this little more carefully. So, what is this angle theta for any given point? How do we so let's define here. So, we will call the angle theta to be the eccentric angle of the point P. So, let us draw the ellipse. Suppose this is our ellipse x square by a square plus y square by b square equal to 1. Then we have this point is a comma 0 minus a 0, 0 b, 0 minus b. This is the origin O. Now, here is a general point P whose coordinates are a cos theta and b sin theta. And where do we see this angle theta in the picture? So, now if you see this, the x coordinate of the point is a cos theta. So, this length is a cos theta. Now, if I want to take this point, so if we take angle theta with the positive x axis, then the x and y coordinates are given by, let me write this point q as a cos theta and a sin theta. So, if I take this angle theta, then this point q is has the coordinate a cos theta, a sin theta. In this case, we are taking b to be less than a. So, this point is outside this ellipse. Now, where is this point q? So, if you see this point q lies on the circle. So, the point q lies on the circle x square plus y square equal to a square. So, this is the circle which is again centered at the origin, but the radius is equal to 1. So, if I draw this circle, this is the circle which has radius equal to a and center is same as center of the ellipse. So, this point q lies on the circle and has the same x coordinate as the point P. This is the circle whose radius is a. So, we can find this angle theta by any point on the ellipse x square by a square plus y square by b square equal to 1. This can be obtained by taking the point on the circle x square plus y square equal to a square, which has the angle theta with the positive x axis, and then we drop the perpendicular to the x axis, and then this intersects at the point P on the ellipse, whose coordinates are a cos theta, b sin theta. Any point on the ellipse given by a cos theta, b sin theta is on the vertical line through the point on the circle x square plus y square equal to a square at an angle theta with the positive x axis. And what is the ratio of the y coordinates of this? If you see a sin theta and b sin theta are the y coordinates of q and p respectively. So, the ratio of the y coordinates of P and Q is B sin theta divided by A sin theta, which is equal to B by A. So, in fact, you can use this to describe the ellipse. So, if I want to describe the ellipse x square by a square plus y square by b square equal to 1, you first look at the circle of radius a centered at origin, and then you look at any point q on this circle, then the point P on the ellipse will be on this vertical line through this q, and where is this point P? This is such that the ratio. So, if I call this q m, then the ratio P m divided by q m is equal to B by A. So, that means that P m is equal to B by A times q m. So, you take this point P with whose y coordinate is B by A times the y coordinate of q, and if you keep varying the point q on the circle, what you get is the ellipse x square by a square plus y square by b square equal to 1. So, next we will do one problem. Determine the locus of the point of intersection of tangents to the ellipse x square by a square plus y square by b square equal to 1, which meet at right angles. So, what we want is to determine the locus of the point of intersections of tangents which meet at right angle. So, let us write what is the equation of the tangent. So, solution equation of the tangent whose slope is m is given by y equal to m x plus c with c square equal to a square m square plus b square. That is, we have equation is y equal to m x plus square root of a square m square plus b square. So, once you know the slope, you can write the equation of the tangent. Similarly, what is the equation of the tangent whose slope is minus 1 by m. So, the equation of the tangent which is perpendicular to the above tangent is y equal to, so the slope should be minus 1 by m. So, minus 1 by m times x plus a square times minus 1 by m square plus b square. Let us write this equation 1 and this is our equation 2, y equal to minus 1 by m x plus a square by m square plus b square square root. So, if h comma k is the point of intersection of these two tangent, if h comma k is the point of intersection of 1 and 2, then we have k minus m h is equal to square root a square m square plus b square and m k plus h is equal to square root a square plus b square m square. So, h k lies on both the equation 1 and 2, this gives us these two equations. Now, to find the locus of the point of intersection, we need to eliminate m from the above two equations. Let us call this 3 and 4. So, we need to eliminate m from equations 3 and 4. So, if you square and add 3 and 4, squaring and adding equation 3 and 4 gives k minus m h square plus m k plus h square equal to a square m square plus b square plus a square plus b square m square, and this gives k square plus h square times 1 plus m square equal to a square plus b square times 1 plus m square on simplification, and that is same thing as h square plus k square equal to a square plus b square. Therefore, the locus is x square plus y square equal to a square plus b square. So, locus is a circle, this is a circle centered at 0 0 and radius square root of a square plus b square. Okay, so we will stop here for this lecture. In the next lecture, we will discuss some more problems on ellipse, and then we will talk about tangents and normal to hyperbola. Thank you.